All right, question 8 has some similarities with question number 7, but it also has some differences, and we need to be careful. So let's just line up and kind of write down the information that we have. So we're launching at a speed of 35.0 meters per second, and we're doing this at an angle of 50 degrees. Now here's what's happening in this problem. So we're launching at this speed, so we have an angle theta and a u, and let's just be clear, that's u and that's theta. We go up into the air, we reach the top, and then we land. Okay. So we have a time up to the top and we have a time down, just to be clear. Now the first thing is, let's go ahead. We're going to get 35 times the cosine of 50 for the x component, and 35 times the sine of 50 for the y component, just to be clear. And so when we actually work out those numbers, we're going to end up getting 22.5 meters per second and 26.8 meters per second here. So let's go ahead and organize that information. X naught is always 0. We don't know how far it's going to go horizontally. And we don't know the height that it's going to get up to. Okay, so this is unknown. Ux is the 22.5 we got here. And let's make that meters per second. We have an unknown t here. Now, s is an unknown. Uy is the 26.8 meters per second that we have here. Now, one thing I want to be clear on. To figure out the height, what we're saying is that we launch into the air, and we're at the very top. We only have the horizontal ux component of speed. Vy is actually 0 at the top because we're trying to get the height. So that's why this ends up being 0. Our acceleration is 10, and we have an unknown time. So we can actually go ahead for part A and get the, or I called it part D, to get the maximum height reached. So that's going to be v squared. Vy squared is uy squared minus 2as. Just follow the equations that I put there. That's going to be 0 squared at the top is 26.8 squared minus 2 times 10. Sorry, that's not 10 times s. I don't like that because it looks like I crossed it out. Let me just edit that really quick. Yeah. 2 times 10 times s. And that's going to give me 20 times s equals 26.8 squared. And when we simplify that, we're going to end up getting a height of about 36 meters when we finish. All right, so that's the height. Now, one thing I want to be clear on, the time that we get, let's go ahead and actually get the time it spends in the air right now. So for part E, the time up is going to be Vy equals negative AT plus Uy, using this formula here. So that's 0 in the y direction at the top equals negative 10 times t plus 26.8. When we simplify that, we're going to end up getting a time of 2.68 seconds. Want to be clear, this is just the time up. So I actually should not. So t is 2.68 seconds, and this is just the time up. So the total equals 2 times 2.68, which is, let me make it, So 2.68 times 2, which is 5.36 seconds. Now for part F, we want to know the horizontal range it covers. So that's going to be x is u x t plus x naught. Let's put in our numbers. It's going to be x equals 22.5 from up here times the 5.36. And so when I actually simplify that out, that's how I'm going to end up getting 120.6 meters. Like I said, we're going to worry more about sig figs next semester, so we'll just write it down like this. So we get 120.6 meters for the horizontal range. Again, just to note, Vy is 0 at the top. The time that we get here of 2.68, that's just the time up. We need to go ahead and double it to get the total time, and then we use that to get the range. So that's question number 8.